Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the British Embassy at Autonomy Day. Basically all sorts of autonomous vehicles, air vehicles, land vehicles, as the one we've got behind us here. And we have Dave Pirozzo, who is with the Tank Automotive Research and Development and Engineering Center out in sunny Michigan, where you guys are doing the Lord's work with all sorts of automotive and vehicle technologies. This is one of the larger unmanned systems that are here. Walk us through the program, what you guys are trying to achieve with it.
Sure. So we're trying to increase the amount of autonomy in our vehicles so that we can help to remove soldiers from dangerous situations, as well as be able to kind of multiply manpower, get vehicles without soldiers in them, maybe a half dozen vehicles operated by one or two people. We have a variety of sensors that allow us to detect obstacles in the environment and navigate, and we're constantly developing new algorithms to help us better navigate those situations at higher speeds more reliably.
One of the challenges, as we saw with the DARPA Grand Challenge many years ago, was that the vehicles were moving very, very slowly, but the speeds of those have really picked up over time. You guys, walk us through the kind of sensors you guys have set up, because navigating is a bit of a challenge, especially in the sort of challenging terrain that you guys are also trying to operate on. It's one thing to operate in roads where there are known confines. You guys are operating actually without any known confines, so the system doesn't have those sort of cues on how to stay on course, for example.
Right. Yeah, so we use a lot of the same sensors that the commercial environment uses, maybe some ruggedized, versions of them. The Velodyne 32 LiDAR, that's kind of our primary sensor for detecting our environment. We have a forward and rear-facing stereo pair. Those have some filters over them as well that allow us to determine different materials in the environment, so we can determine rocks from grass, from pavement. That particularly is important for off-road environments, so that you can drive through tall grass, you don't consider it an obstacle. Other than that, we have a variety of frequencies for our radios that we operate on. In the center we have a IR and color camera that allows the operator to drive remotely if they need to. And most of the rest of the hardware is under the seats. We have computers, extra batteries. We have a localization box that combines GPS, IMU, gyro, and wheel encoder data for a high precision position of the vehicle.
And just for our audience, LiDAR is a laser measuring system, effectively, that laser radar, if you will, ultimately, instead of radio waves. So what sort of speeds is this vehicle capable of navigating, especially in totally unfamiliar terrain?
Okay, so typically sort of the off-road environments, we operate around 10 miles an hour. More on-road and trails, we've been testing up to about 25 miles an hour.
And what's sort of the next generation of this technology? Where do you want to take it so that it's actually combat applicable for the United States Army? I mean, nobody wants to be riding around in a 10-mile-an-hour vehicle if they can possibly help it, depending on the situation. What is that? What are the parameters you need to achieve before the tactical army really wants this system as part of their battle rig?
So definitely reliability is kind of the one thing that we're working hard to achieve. I think more the on-road, secondary unimproved roads is sort of the first place that we'll be able to, get this out into the field. Some of the larger cargo trucks being able to do convoy-type operations. And
the technology is completely scalable, so you could put this, whether you want on a tank, on a heavy equipment transport, or just even a regular truck.
Yes, so this is actually probably one of our smaller vehicles. A lot of the other, FMTV, LMTV type vehicles is using the same sensors and same software is what we target. So,
Dave, thanks very much, and best of luck on the program. Very, very cool.
Thank you. It's great to meet you.